Evening. I'm glad to join you tonight and have the opportunity to speak on really one of my favorite topics. After having been a monk for many years, Tibetan Buddhist monk, living with Tibetans, a lot of that time in India, when after 14 years leave of absence from Western civilization, decided to come back and try to integrate what I'd learned from the Tibetans with my Western background, I made a beeline for physics. And that was at Amherst College when I was, 34 years old, decided to finish my undergraduate education. And so this was my first venturing back into the field of science. It was in physics. Since then, a lot of work with neuroscientists, psychologists, and so forth. But I'm coming back to physics again and have a renewed love affair. The topic for tonight is one that I think should very properly arouse a strong sense of skepticism, where Buddhism and physics converge. How could they possibly converge? And that is, if you look at the methodologies, how do Buddhists, traditional Buddhists, Buddhist monks, yogis and so forth, how are they inquiring into the nature of reality, primarily by way of meditation? And the primary emphasis of that is looking into the very nature of awareness itself. Not exclusively, but that's certainly a central theme. So we have yogis living in caves in the Himalayas, or in little grass huts in India 1,500 years ago, meditating, allegedly making discoveries. But in terms of sheer methodology, also a contemplative methodology. And then we have physicists going back to the time of Galileo. Where are they directing their attention? Not to their minds at all. They're directing their attention entirely outwards, and moreover, they're directing their attention outwards by way of increasingly sophisticated technology. Galileo with his 20-power telescope, right onto the Hubble telescope. Tibetans had nothing like that. The ancient Indians, nothing remotely like that. And then this marvelous quantitative analysis that is characteristic of all branches of physics. Buddhists don't have any of that. So how could there possibly be any convergence? The methodologies are so different. Just for starters, and then we take Buddhism. A lot of people, especially people who don't understand Buddhism particularly well, regard Buddhism rather generically as a religion. Physics is just a paradigm of science. So again, people approaching their understanding of reality by way of religion, that pretty much always entails some appeal to authority. Buddha or God or Jesus or Muhammad, but somebody who really knows what's going on, and then we take their word for it. The physicists are doing just the opposite, aren't they? They're appealing to nature. And if you want to get a Nobel Prize in physics, refute your mentor. Find the highest mountain behind you, whether it's Newton, whether it's Maxwell, whether it's Max Planck, whether it's Einstein. If you can refute them and do it in a compelling fashion, oh, bully for you. You get a Nobel Prize. You don't hear too many Buddhists getting a Nobel Prize for refuting the Buddha. And so how people following something that certainly walks like a duck and quacks like a duck, in some respects, Buddhism certainly looks in some respects like a religion. Physics is clearly a science. How could there be any convergence that's not just smoke and mirrors? So shall we stop there? I'm inviting you to be skeptical. And in terms of presenting my case, that there is in fact at least a possible, meaningful convergence. The power of what I'll be presenting, if there is any power to it at all, will not be the power of just sheer reasoning, that you'll go out of there, or that I anticipate, or even hope that you'll go out of here thinking, by gum, he's right. Everything he said was so compellingly argued, it must be right. I don't think so. What I am suggesting is that there are avenues of empirical inquiry that may give rise to empirical insights that may suggest a profound convergence. So this is not just an exercise in philosophy. This is an opening of a strategy for combining, integrating methodologies from physics and Buddhism and seeing where that might take us. But I want to step back because I love history. So I'm sorry, you have to take a little dose of history. The dose of history here is to pinpoint or focus especially on a mindset, above all a mindset, that was a tremendous impediment to scientific inquiry and scientific discovery. If I give just one quintessential phrase. It's from the American historian Daniel Boorstin. The greatest impediment to discovery is not ignorance, it is the illusion of knowledge. It's thinking we know something and we don't. But since we think we know it, we feel that there's no reason to question it. That's the greatest impediment. Ignorance is sweet. Not that I would aspire for it. I have as much as I can handle already. But ignorance is innocent. Ignorance is clean. Just coming out and saying, I don't know. That's not an impediment. That's just being honest. How could that possibly be an impediment? That's clean. But the illusion of knowledge can be very problematic. If we go back to the time of Galileo, and we see what was he resisting, and Francis Bacon resisting, and René Descartes, what were they resisting? What are they rebelling against? It was this medieval scholasticism that dominated European thinking for a few centuries. And it had a very clear-cut hierarchy. And that is, above all, we will bow, we will submit to divine revelation, supernatural revelation. God's own words, by way of the prophets, by way of Jesus, by way of the church councils, which are believed to be, blessed by, guided by the Holy Spirit, by God's guiding hand. That trumps everything in this medieval picture. But of course, in this medieval scholasticism, what they did, especially Thomas Aquinas, was taking biblical theology, centuries of biblical theology, fusing that with a stroke of extraordinary brilliance, fusing Christian biblical theology with Aristotelian philosophy, Aristotelian reason, Aristotelian physics, and so forth. But here's the famous phrase, philosophy is the handmaiden of theology. Reason is subservient to divine revelation. In the final analysis, if you want to be saved, you're not going to get there by thinking really smart thoughts. You're going to get there by submitting to, bowing to, accepting. Grace accepting divine authority, which transcends the limits of your reasoning, quite possibly, and certainly transcends the limit of your experience. So reason is there to illuminate, to clarify what we know to be true, or at least have an illusion of knowing to be true, namely divine revelation. And then finally there's just experience. And that is, what do we actually perceive of the world, whether of the world around us, or in the Cartesian sense, if we apply introspection, start observing our own minds, what do we observe when we do so? Experience has to be in conformity with reason, the reason in conformity with revelation. The Bible does not need to conform to Aristotle. Aristotle needed to conform to the Bible. People's experience needed to conform to medieval scholasticism, and if they had experiences that did not, they didn't count. There were type of experiences that didn't count, because they couldn't possibly be true, because they were not congruent with, or in accordance with, divine revelation, and the reasoning that backed that up. So there was a certain mindset, and Galileo challenged that, saying that in terms of the supernatural realm, the nature of God, the Trinity, heaven and hell, the nature, Jesus' divinity, we leave that to you. We leave all those supernatural themes to the theologians. You trump everybody, we grant you that. But he was coming in for turf. It was a turf war. That's why he was imprisoned, got house imprisonment. It was a turf war. It wasn't just that he discovered craters on the moon or spots on the sun. It was that he was demanding of the church, there's a domain where we will not simply acquiesce to whatever you say, and that is the physical universe. And we will observe it, we will make our observations, and if they are incompatible with Aristotelian thought, assertions, assumptions, so much the worse for Aristotle. And if something contradicts a literal reading of the Bible, well then you just better think about the Bible again and interpret it differently. When you are in charge of all the turf, you don't really want an interloper coming in and telling you, by the way, we're going to just take the physical universe, if you don't mind. You say, well, we kind of like the physical universe. We like this unified picture where everything is under one umbrella and we're calling all the shots. He said, and they said, he went to prison. Bigger guns. What I'm suggesting here is that we are right now in the midst of a similar type of hierarchy. Clearly, medieval scholasticism is ancient history. We look at it as a historical curiosity. as we pick apart Aristotle, and most of us pick apart any kind of absolutely literal reading of the Bible, the 7,000-year-old universe and all of that. But now we have, instead of supernatural revelation, we have nature itself is the final arbiter. Nature decides what is absolutely true, natural revelation, and absolutely not supernatural revelation. In science, if you at any point in biology, chemistry, cosmology, geology say, oh, and by the way, this is true because it says so in the Quran, or in the Bhagavad Gita, or in the Dhammapada, or what have you, well, you just counted yourself out of the scientific community. In that breath, you've just excommunicated yourself. The only arbiter is what nature reveals to us. Nature reveals, and then we apply our reasoning, especially in modern science, quantitative reasoning. Let us make sense of it. Let us, if we can, identify the mathematical laws of nature that are gained through reasoning, sifted from, by a process of induction, sifted from the data, the appearances, the revelations that nature herself presents to us. Reason will sift that out, and then finally there's experience. I'm putting it at the bottom again. You might find that quite odd. But once again, what type of experience counts? I've read the magazine The Skeptic, which is in some respects, one of the most dogmatic journals I've ever read. And very clearly they'll come back and say, your experience, if you see a UFO or you have some extraordinary experience, well, your experience doesn't count. It's the experience of scientists in a lab where it's third-person corroborated and all of that kind. Their experience counts, but your experience, give me a break. And so now it's only certain types of experience are counted as legitimate experience, just as in 16th century. There were apparently medieval scholastic philosophers who refused to look through Galileo's telescope because they were sure if they saw anything that was incompatible with Aristotelian astronomy, Aristotelian physics, if anything they observed didn't conform to Aristotle, then it must be false. It must be an aberration of the lenses. It must be an artifact of the system of measurement. And therefore, we don't need to look. Because if we look and find something that is in accordance with Aristotle, then ho-hum, we already knew that. If we see something that is not in accordance with Aristotle, can't possibly be true, so we have two reasons for not having to look through the telescope. Thank goodness they didn't win. Principles of scientism. This is a creed, it's a dogma, it's a belief system. It may actually be true. I don't know. But it does have certain tenets, and we can trace these back to the mid-19th century. Among many people, here's simply one, Auguste Comte. Here's how he put it. They called it positivism back then. It's called scientific materialism. It's called materialistic monism. It's called by many names. But one is scientism, as the more fundamentalist branch. Here, the basic tenets. Science is our only source of genuine knowledge about the world. Does that sound familiar? The Bible is the only authentic Word of God. I mean the Quran. No, I meant the Bhagavad Gita. No, I mean the Tao Te Ching. No, I meant the Buddhist canon. Or Mary Baker Eddy. I mean, somebody must have the only way. This is a big deal in the West. We seem to be very keen on people having the only way. I guess it's kind of like Linus and a security blanket. If I've got the only way, that really gives me an assurance, and it gives me the assurance you're really wrong. I suppose there's some comfort in that. But I can understand, I can actually, as much as I think this is absurd, I can also be sympathetic to it, because if we look at the late 19th century, what other discipline in academia, in terms of understanding the natural world, not simply human customs and so forth, human history and so forth, but in terms of understanding nature, what other discipline had come to consensual knowledge and had made such progress and had all these wonderful perks coming out of locomotives, and wristwatches and all these kind of things, technology? Where was there a success story like that of modern science from the time of Galileo till the time of, let's say, James Clerk Maxwell in the 1880s and so forth, 1870s? Where was there a success story that was comparable to that, where from generation to generation it was clear they were learning more, they agreed, they would perform new hypotheses, put them to the test, and agree, and agree, and agree, and it was just so juicy. It worked so well. Who is doing anything like that? The theologians? Not by a long shot. Theologians of what kind? Greek Orthodox, Roman Catholic, Protestant, Baptist, or Lutheran, or Pentecostal? And let us not even talk about the Jews and the Muslims and the Christians and the Buddhists and the Hindus and Taoists and so forth. Where's the consensus? Where were they growing in a body of knowledge and coming to consensus? Nowhere in sight. In fact, especially with Christianity, they seem to be running backwards, moving away from this inexorable movement of science, pushing back the history of the planet from 7,000 years to, some hundreds of millions, they thought back then. The relative motion of the earth and the sun, and so on. Theology seemed to be going into a defensive mode and losing the battle, frankly. But not making any great gains itself. It was just basically retracting. Philosophy, where was there any consensus among 19th century philosophers? From William James to Schopenhauer to Hosea Royce, and the list goes on and on. Where do they really agree on anything? Unless it just happened to be by accident. And what can you point to in terms of the development of philosophy that says, in the 19th century they believe this, but now in the 20th century they've got this great consensus? I wish. But I don't see it now either. It's not to say philosophy is a waste of time, and nor am I implying that theology is a waste of time. But for those who are pretty skeptical, they might say, we've got these three major disciplines, clearly there are others as well, but science is the one that's really working. So why should we not conclude it's the only source of genuine knowledge about our world? Because it seems to be the only one that works. Science, says Comte, it is the only way to understand humanity's place in the world. So not only just the environment, but how do we fit in? By this time, Darwin had come up with this magnificent theory. 1859 was when that came out. So, that's how we fit in. We're not sui generis. We're not in a category all by ourselves, separate from all of creation, just plunked down on the sixth day. But there was this course of evolution over hundreds of millions, or perhaps even billions of years. That's where we fit in. And it was science that revealed that, not theology or philosophy. And therefore, science provides the only credible view of the world as a whole. So it's the only methodology. It shows where we fit in, and in terms of its conclusions, rely on science, because that's the only one that's credible. Where's the consensus in any other field? Sounds pretty good, doesn't it? I think it's fundamentally wrong, but it sounds good. But now, what is this world that is being understood? This natural world, emphasis on natural. It consists, according to this view, only of physical phenomena that can be explained according to the laws of physics and biology, and there are no non-physical influences in the physical world. That's really the gist of it right there. I see this in the media all the time nowadays. This is not some kind of artifact from the 19th century, some relic that we pick out of somebody's grave. This is in the New York Times science section, last week, or Time magazine, or many scientific journals. If one does not embrace that assertion right there, the words start coming out. I see them as almost like mantras. Magical thinking, supernatural thinking, irrational thinking, mystical thinking. You either accept this, or you're just bloody stupid, or ignorant, or you've fallen into supernatural, magical thinking. It's kind of just more insulting than anything else. Like, come on, this is what's going on. Now bear in mind, all of this was coming out in the late 19th century, when Lord Kelvin made a number of real gaffes. He was a brilliant physicist, but boy, if he wanted to make a mistake, he did it flamboyantly. And this is one of them. There is nothing new to be discovered in physics now. And he would tell his graduate students, don't go into physics anymore, all the fun's over. Go into something else. Biology looks pretty good, but we did it. We finished. Right? This is about 20 years before Max Planck started quantum mechanics, 25 years or so before that guy, what was his name? Einstein. And then all their colleagues, Werner Heisenberg, Niels Bohr, and so forth, there turned out to be something new after all. But that was not the assumption in the late 19th century. It looked darn good. It looked like Newton had been so brilliant, so brilliant, and the ensuing couple of centuries had so unpacked it so beautifully. And then the integration, this whole principle of conservation of energy was such a great element to be introduced there. Darwin seemed to really have nailed the whole nature of life and its evolution. It seemed like, we've got it. That was exactly the attitude of the medieval scholastics in the early 17th century. We've got it. There are questions we no longer need to ask because we already know the answers beyond a shadow of a doubt, so don't doubt and don't question. But I want to come back to this natural world. Natural world. Often people, when they want to use a more benign term than scientism, which has actually a pejorative connotation to it, they'll use the word naturalism. Naturalism. I wanted to be a naturalist when I was in my teens. I wanted to be a wildlife biologist. Naturalist. That sounds kind of nice, doesn't it? Rather than, do you really want to be a naturalist or an unnaturalist? I want to be a naturalist myself. I want natural food. I want organic food, not unnatural food. None of that genetically cloned stuff. So naturalism has a nice ambience. And natural world. So what is this natural world for which science, is our sole source of knowledge? Well, it turns out there are many notions of what this natural world is. Now, what they all agreed, if we look at Richard Dawkins with his whole diatribe against theism, and Daniel Dennett, the same thing, Sam Harris just going ballistic on this theme, and Hitchens was the latest screeching voice against God. What they all agree is we have to be naturalist here. What is this natural world? They know that what isn't true is supernaturalism. This is like heresy. If you're a supernaturalist, well then we're just going to have to excommunicate you. Because you're just not in our tribe. You can't be a scientist and be a supernaturalist. Because scientist means you're a naturalist. What is the natural world? Well, many people equate it with the physical world. That kind of like, that makes sense. Physical world, so space, physical space, time, matter, energy. That pretty well should do it, right? Physical. The problem with physical, the problem with that equation, is the very notion of the category of the physical is a moving target, and it's moving now. If we go back to the notion physical in Descartes' writings in the 17th century, that was one notion of physical. But as we move ahead over to Newton, now physical means something else, and his notion was somewhat different from Leibniz's. And then we keep on moving forward, we get into the realm of energy, of electromagnetic fields and so forth. Are they physical? Are they not? Gravitational fields, are they physical? What are they made of? Newton was deeply troubled by this notion. There could be empty space between the sun and the earth, and it would still hold this great big chunk of dirt, the earth, in the orbit around the sun, and it didn't. How did it do that? These gravitational fields. What in the earth is a gravitational field? The answer is nobody really knows yet. A curvature of space-time? That didn't satisfy me too much. So the physical, the very category of the physical, I think a crucial element here that is often overlooked is the very category of the physical, the demarcation between physical and non-physical, is created by human beings. Nature didn't whisper into the ear of the physics department at MIT, this is the real definition. No physicist prophets that just got it straight right down the pipeline from nature's mouth to their ears. This is what I really mean by physical. It's a moving target, and it moved no more radically in the history of modern physics, that is going back to Galileo, than in the 20th century, with quantum mechanics especially. Quantum mechanics. An unmeasured quantum mechanical system is described as a probability function, described mathematically by Schrödinger's wave equation. It's a set of probabilities. It's a complete mathematical abstraction, but you can measure it. It's called a quantum measurement. And you move from potentiality to actuality. How can you measure a potentiality, which is a mathematical abstraction? We don't even need to go to quantum mechanics. Ever since 1887, the great Michelson-Morley experiment showed that there is no mechanical explanation for the propagation of electromagnetic fields through space. If there were an ether, it would work out really well, because then the ether would ripple, just like water ripples with waves passing through it. But if there's no ether, there's no medium to propagate electromagnetic fields, which means there's no mechanical explanation, which means the only way to describe an electromagnetic field is in terms of pure math. It's not some chunky stuff out there moving through space and rippling the medium space, going like that. So what's physical now? Is a probability function physical? Is a mathematical description of an electromagnetic field physical? Is dark matter physical? How about dark energy? Is that physical? How about the laws of physics? E equals mc squared, F equals ma. Are they physical? They're part of the natural world, aren't they? The laws, the mathematical law, are they physical? What on earth does it mean? And Werner Heisinger made the comment that there have been two large motifs, or ways of understanding the physical, tracing back to Democritus. Everything boils down to chunky little things, atoms. To Pythagoras, everything, the whole physical world, boils down to mathematics. Werner Heisenberg, one of the great architects of quantum mechanics, said, the debate's over. If you're trying to boil down the whole physical universe to little tiny chunky stuff, you're lost. Because quantum mechanics says it just ain't so. An unmeasured quantum mechanical system does not consist of little elementary particles with real location and real velocity prior to the act of measurement. It'd be really simpler if they did, but they don't. There's virtually complete consensus among quantum physicists that that is not the case. So what does the word physical even mean anymore? And what we know is it's become very ethereal, and what we know is there's no consensus. So that would be kind of limp, or just kind of leave you natural world equals something that we don't really know what it means. How about the objective world? Science is objective, right? That's its great strength. Galileo looking outwards, Darwin looking outwards, Einstein also looking outwards to configurations of space-time. Is that the natural world? What we can actually appears to us objectively, what's really out there? That's like saying the only good food is steak. If you want to believe that, that's perfectly fine, but what's wrong with Jell-O? That is, what makes the objective world more real than the subjective world? Just because you say so? Shall we hold a church council and just say, decree that the objective things are somehow more real than the subjective? It's not real, it's only in your mind? Are you out of your mind? What is more real than your sufferings and your joys, your hopes and fears, your thoughts, your aspirations, your memories, your sense of personal identity? What's more real than that? Human interrelationships, are they objective? What's more real than that? So that just seems to be sheer whimsy, to equate natural world with objective world, as if we're just going to decree before we even start that the realm of the mind is not natural. Well, that's like, I don't know, saying some ethnic group is just inferior because we said so. They kind of look inferior, don't they? You know, pick your choice, Anglos, whatever. That's just whimsy. That's not even a scientific hypothesis. That's just like, whatever. If you want to play that game, that's like Parcheesi. Okay, make up your rules, but nature never said that the objective world is somehow more real than subjective mental events. That's just silly. But it does happen to be what physics, biology, chemistry are good at. So should we say the natural world consists only of what physics, chemistry, and biology are good at looking at? That's letting our very view of reality be defined by the limitations of our systems of inquiry. That's Parcheesi all over again. That's just a game. That's silly. How about just saying that the natural world equals the world of physics? Physicists might love that. If you want to just let us be the arbiters of all of reality? Well, okay, just give me a raise. You know. But why should we say that? I mean, physics is a magnificent discipline. And it's gone through not only one, but now two great revolutions. Starting with Copernicus, and now the second one in the 20th century, which is not over. A very important feature here. But that's just like designating a certain group of people like a college of cardinals and saying, okay, you just tell us what's true. Well, okay, if that's what you want to do, but then just call it a church. And if you're just going to say that physicists get to tell us what's true and not true, then just call that a church. Nature never said that physicists have some kind of a priority over biologists or over psychologists. So that's just whimsy. Or so many people in the life sciences, and especially the cognitive sciences, leaning very heavily on neo-Darwinism, and by that I mean Darwinism with the marvelous advances since his time, especially in genetics, starting with Mendel right through the Human Genome Project. As if this defines, this is the very, now we know what's really going on. Well, I believe Darwin had brilliant theories, tremendous amount of truth in it, but to simply equate the natural world with that, I think, well, okay, it's just an opinion. If you want to have that opinion, fine, but why call that science? And finally, this is not an exhaustive list, but this is one that comes up quite frequently, and that is if anything has any impact on something we know to be physical. Let's take an example, the human brain. Human brain is physical. I mean, I would have no qualms about that. It's made out of cells, molecules, atoms, elementary particles, electromagnetic fields, electrochemical system. If that's not physical, then I don't know what would be physical. So the brain is certainly physical. That's clear. But now, shall we say that anything that can possibly influence the brain, which is physical, must be physical because it influences the brain? It's kind of like hegemony. You know, like here's a domain. If anything even touches our domain, then it's part of our domain. Why should we believe that? There were good reasons for believing that in the late 19th century. From the time of the mathematical formulation by Helmholtz, Hermann von Helmholtz, 1864 or something like that, the mathematical formulation of the principle of conservation of energy. It looked like the physical universe was absolutely hermetically sealed, that nothing could impinge upon the physical universe, not the Milky Way, not the human brain, two physical systems. Nothing could impinge upon it, nothing could have any impact on any aspect of the physical universe, unless it itself was physical, because if there was something non-physical impacting the physical, that would violate the principle of conservation of energy. So it looked very tidy. This really warmed the cockles of the hearts of people who embrace this as a central pillar of modern physics, and to some extent it certainly still is. It's a brilliant principle, and it's about as full of holes as Swiss cheese. And it's called the Heisenberg uncertainty principle. That goes for energy and time. There are, and this is not New Age physics, this is just core quantum mechanics, there are violations of the principle of conservation of energy. The shorter the violation, the shorter the violation, the larger the magnitude of the violation can be. So it's like if you steal from the bank, if you're really quick, you can steal a lot of money. If you're slow and lethargic, you only get $10. This is core quantum mechanics. It does not hold. It is not hermetically sealed. You can cheat. You can take quick withdrawals out of the physical universe, or you can insert. And when we have things like the placebo effect, what a mystery. That was one of the things they never saw coming. It shouldn't be there. If you're a good, strict materialist, the placebo effect just should never happen, and we should never have any double-blind experiments, triple-blind experiments. We would just say, take this, tell me whether it works. And it shouldn't matter whether the person has faith, belief, expectation, desire, has trust in the person who gave them the pill. It shouldn't matter. Because after all, it's just subjective. Your faith, belief, trust, and so forth, they're just subjective, right? They influence the brain. These feelings, the trust you may have in your physician, the feeling, that's a really cool pill, I bet that works. You know, or that looks like really a really flaky pill, that's homeopathy, that's got like 1 out of 10 million parts, I doubt it. So then you maybe knock it out with your skepticism. These kind of things of belief and skepticism have a very clear bearing on the efficacy of medicine, or there's the nocebo effect. You can take something that's neutral and make yourself sick because you think it will make you sick. The nocebo effect. That shouldn't be there. This is a very hot topic, not only the placebo effect, but this whole theme of neuroplasticity, which is getting very hot. Sharon Bagley wrote a marvelous book on this, Train Your Mind, Change Your Brain. It's first-rate science, by any criteria. It's first-rate science, showing how experience, thoughts, emotions, imagination, visualization have quantifiable, measurable impacts on the brain, the immune system, the body as a whole. But you know, it shouldn't have been that much of a mystery. You want to say something really weird? I did that. I decided to raise my hand, and then I put it down. I had this thought, and then it went into a desire, and then desire went into an intention. You want to see it again? Mind over matter. We can run that experiment a number of times just to make sure that you saw it wasn't a quirk. It wasn't an anomaly. There was no tricks. There was no hidden wires here. Mind over matter. Let's go back to history. Galileo, I love him. Want to read a really good book? Read Galileo's Daughter. Delightful book. Galileo took this bold step. I think he's the paradigm of the modern scientist. He was the template, much more so than Copernicus or others who preceded him, Tycho Brahe, more than Kepler. he brought in this theme of the rigorous observation of material phenomena, whether it was celestial phenomena, whether it was rolling balls down a ramp, a myriad of other terrestrial experiments that he did in the field of kinematics, dynamics. But it was not just observing, because Aristotle observed. He was not just sitting in his room philosophizing. He was out there observing. He was a great empiricist. But Galileo brought in sophisticated quantitative modes of measurement, the likes of which had never been used before. The telescope had never been used for astronomy. And with this unprecedented step of sophisticated, rigorous, sustained observations and, of course, experimentation, because he was a brilliant mathematician and an experimentalist and an observer, he truly, I think he more than anybody else, launched the first revolution in the physical sciences, in astronomy and in physics. He was marvelous. A bit arrogant, but gosh, he was good. And then Darwin, 1859, after about 25 years of meticulous, rigorous, very careful observation of biological phenomena in the Galapagos, in England, and various places, observing and observing, reflecting and observing more and reflecting, came up with his brilliant theory. But had he not spent those 25 years in very careful observation, if he had just been a philosopher sitting in his room and thinking, gee, I wonder what happened, maybe it was evolution, that would not have been a scientific theory. It would have been musing, one more groundless hypothesis, one more philosopher's speculation. But he carefully observed in ways that nobody else had done, except for that guy Wallace. But Darwin did it better. And he launched a true revolution in the life sciences. And when I use the word revolution, I'm using it in a very specific way. When we speak of a revolution in the physical sciences, I'm saying once the revolution has taken place, you can never look at the physical universe in the same way again. Not if you got it, not if you understood the import of the revolution that took place. The Copernican revolution, the Galilean revolution, as soon as you get it, then the universe just looks different. Your take on it is just fundamentally different, and it won't go back. It might go forward, you might develop further, but it will not go back to what it was prior to the revolution, and likewise with Darwin. Seeing human existence embedded in an ongoing evolutionary process governed by natural selection, and now we know genetic mutation in relationship to a changing environment. As soon as we understand that, we cannot look at life the same way anymore. As static species that were plunked down someplace by something or someone, can't do it anymore. We can't go back. It's fundamentally different. We are mammals. We are primates. And we can't back out of that. Now let's go to William James. Latter part of the 19th century, died in 1910. He was brilliant. I think he was to psychology what Einstein was to physics. But Einstein's revolution, because that was the second revolution with quantum mechanics, that one actually took off. The revolution that William James was proposing was aborted. William James, like Galileo and Darwin, proposed that the phenomena that were of interest, and for William James, nothing more of greater interest, I think, than the nature of mental phenomena. He defined psychology as a study of the very stuff that we experience subjectively, thoughts and images, memories, emotions, desires, fantasies, dreams, the whole range of subjectively experienced mental phenomena. He said, that's what psychology is about. That's what we should study. And therefore, since that's what we're trying to understand, just as Galileo, first, foremost, and always primarily relied upon the observation of celestial phenomena, Darwin, first, foremost, and always relying upon the observation of biological phenomena, James said, do the same thing for the mind. First, foremost, and always, he said, let the primary thrust of your inquiry into the nature of the natural phenomena of the mind be that of introspection, which means observe them. And it would be nice if we could just observe everybody else's thoughts, although I'm not quite sure how nice that would be. But it certainly would give us a lot more data. Right? But we're basically stuck with kind of flaky inferences. Sometimes robust, sometimes just completely off the wall, when we're trying to surmise, to figure out, to draw inferences about other people's mental states, their desires, their emotions, and so forth and so on. Anybody who's been married knows how difficult it is, even with a person you've lived with for years, to keep on, getting a bullseye every time you draw an inference. What was she thinking? What was he hoping? What was he responding to? What was his emotion then? What's going on? And it's hit and miss. So, given the fact that, at least for most of us, we have no direct access no observational ability to directly measure, observe other people's mental phenomena, then we're just stuck with n equals 1. One subject, and say, well, at least I can observe somebody's mental phenomena, mine. And maybe I'm not a species unto myself. Maybe what I observe in my mind is going to be comparable to, in some respects, what you observe in your mind, and then we can get together and cross-reference. So he proposed this rigorous observation of mental phenomena, but this proposal was thwarted, I would say, ideologically, by the hierarchy of scientism. And no sooner was he in the grave than John Watson got out and said, forget William James. Psychology will be the study of behavior, because that's what we're good at. We're good at studying objective, physical, quantifiable stuff. Behavior is. Thoughts, emotions, desires, mental images aren't. So let's continue doing what we're good at and not even talk about the mind. Let's just talk about what we can talk about objectively. And started a roll of 50 years of behaviorism. Some of the more radical behaviors saying mental phenomena don't even exist. Consciousness is a name for something that doesn't exist at all. In other words, they went completely bonkers. They got over it. I mean, I think we're pretty much through that time now. But the fragrance, I'm going to use a nice term, the fragrance of that lingers into the present day. But what I would say, this is my opinion, that had we been able to develop William James's idea, which he did not bring to completion, he just gave us some really good guidelines, but if we had followed that through, it might have occurred that we developed a true revolution in the mind sciences. I would say over the last 130 years, we have not. I would say there's been no revolution in the mind sciences. There have been many excellent insights, enormous amount of knowledge, a lot of it of great value, in the psychoanalytic tradition, in psychophysics, cognitive psychology, social behaviorism, a lot was learned. Affective psychology, personality psychology, developmental psychology. I'm not at all dismissing these. I think they've all had great successes, and there's been a good deal of consensus among them. But a revolution? Who? Freud? I don't think so. Who? Who brought about a revolution? If we look at the assumptions that were underlying the birth of psychology in the 1860s, and then developing more steam in the 1870s with Wilhelm Wundt in Leipzig and William James at Harvard, the basic assumptions are pretty much the assumptions that are widespread now. Where was a massive assumption that's been completely overthrown? That we can say, we can no longer look at the mind in the same way ever again. A lot of people reject Freud out of hand. Brilliant, a lot of insights, a lot of illusions of knowledge as well. So it was the revolution that didn't happen. The revolution that got thwarted by the internal inadequacies and problems, unresolved problems in the so-called introspectionist movement. It was definitely fraught with problems. William James did not have a recipe for solving all the problems, the challenges of introspection. But then they just threw out the baby with the bathwater. And they turned the study of the study of the mind to an objective science. We'll study the mind, we'll study yours. We'll study your mind by way of studying your behavior, your speech, that is your reports of your experience, and now we'll spend lots and lots of money studying your mind by way of your brain. And if we want to just take a shortcut, we'll just say your mind is the brain, and that makes things a lot simpler. One more illusion of knowledge. I said I'd talk about bringing together Buddhism and physics. Buddhism and physics. I think some of the most adventuresome and bold theorists in this whole issue of the role, the nature of consciousness in the larger framework, not just the brain, but consciousness in our universe at large, some of the boldest thinkers in the reading that I've done are not to be found in the mind sciences. They tend to be a pretty conservative lot, and their physics tends to be 19th century physics. The good old days when physics meant chunky stuff floating around in absolute space-time. The good old days. When the physicists rode to their labs in horses and buggies. But a lot has happened since then, and the life sciences and the mind sciences, frankly, I think have not really kept up much. They're just assuming that 20th century physics is irrelevant, and therefore they don't need to study it, one more illusion of knowledge. But Andrei Lint is one of our leading physicists, a Russian, but who's been teaching now for years at Stanford, brilliant theoretician, working on cosmology, the inflationary model of the following the Big Bang and so forth, absolutely brilliant. And he is adventuresome. He's not providing answers here, he's providing provocative questions. One provocative question is worth a ton of mind-numbing data. I think these are cool questions. And illuminating, casting a bright light on illusions of knowledge, which all of us are prone to. Theologians, scientists, philosophers, me, Buddhists, and so forth. Here, a standard assumption is that consciousness, just like space-time before the invention of general relativity, plays a secondary subservient role, being just a function of matter, that is, consciousness just being a function of the matter inside our heads, and a tool for the description of the truly existing material world. That is, it's with consciousness that we can then describe what's going on really out there. But let us remember that our knowledge of the world begins not with matter, but with perception. Matter, like the category of the physical, is a human construct. It wasn't a given to us at some point that nature got really generous and said, you want a definition? Here's a keeper. Never happened. We keep on defining and redefining and redefining, and the same as for the physical, the same goes for matter. Matter is a construct that we sift out of, we derive from our perceptions, our measurements, our visual observations, and so forth. What is primary is our perception. What is derivative is our understanding of and our way of conceiving and measuring matter. It suddenly turns the tables. Rather than simply assuming that matter is absolutely primary and all mental phenomena are derivative or even epiphenomenal, he's saying, let's get real. What we know what we know with greatest certainty are the immediate contents of our experience, our perceptions. Is it possible, here's his juicy question, is it possible that consciousness, like space-time, has its own intrinsic degrees of freedom, and that neglecting these will lead to a description of the universe that is fundamentally incomplete? What if our perceptions are as real, or maybe in a certain sense even more real than material objects? In other words, space-time since general relativity, space-time there is a full-fledged equal partner with mass energy. Right? It was assumed prior to relativity theory that there was an asymmetry between mass energy on the one hand and space-time on the other. That is, you could have a region of space, it's inert. It just sits there. And then a body of matter comes in and it fills it and it changes that space because it got a bunch of chunky stuff in it. But the space wouldn't do anything. The space just kind of sits there and, fill me, you know? It just sits there. So the causal interaction there was one way. Matter influences space. Space, what space influence? It's just nothing, right? Until relativity theory. Until we find, aha, there's another take on gravity. It's not some invisible field emanating out from the sun, but in fact the very space in which the sun and the earth are embedded gets warped by the mass of the sun, and it's because space itself is curved that the earth is going in a straight line, in curved space, right? Or photons from a distant star. It was 1917, I think. Eddington, Sir Arthur Eddington, I believe his name was, got the first empirical evidence that Einstein's general theory of relativity really had some oomph behind it. That is, he saw that there was evidence, clear empirical evidence, that photons bent. When they came near, when they were passing from behind a planet, I think it was Mercury if I remember correctly.